I have the ultimate pleasure to welcome on stage Aneta Petkova, a first-time ISTA speaker and a passionate quality engineer, who is going to talk to us about Machina, a framework that knows its bugs. Thank you.
Hi, everyone. So, my name is Aneta Petkova, and I'm here today to tell you about how we do test monitoring at Honeywell Aerospace, and because I really wanted to see the view from this stage, which is pretty much amazing. Now, I know that this is the last lecture for the day and that you're probably tired, but let's talk some performance. I guess that each and every one of you have researched test performance optimization at a certain stage. I can tell you that I have, and I have researched it a lot. I went through best practices, tutorials, blog posts. I watched a lot of presentations. I actually saw a really good one on this stage last year, for example. And some of them promise to do amazing things. Some of them really do. And the timing that test running takes was really a problem for us at Honeywell Aviazo. But while we were researching performance, we kept adding new tests to our suites. And before we knew it, we realized that we actually had over 150 functional tests, and we executed them on 2 different branches for over 30 quant modifications. This meant that we were running about 1,000 tests each day. And probably some of you are running like 10 times this a day, but we were really proud of ourselves. It was a huge thing for us. And however, we realized that when you have 10,000 tests running every day, they bring something else with themselves. They bring 10,000 test results. And this is something that is pretty often overlooked. Because it doesn't matter how many test cases you have, and it doesn't matter how many test cases you can execute for 1 minute or for 1 hour, if you don't have the capacity to process the results. And at a certain stage, we reached a point where we needed a whole person day to process our daily test results. And I don't know about you, but I don't think that looking to test failures the whole day is anybody's dream job. So we decided that this is something we don't want anybody to do every day. And we thought, OK, we reached a point where we're able to automate our infrastructure. We are able to automate testbed deployment, and obviously, we are running automated test cases. So why not automate the test monitoring process? In order to find a way to do this, we started by looking at our current process. What a person would do when he starts looking through the tests. Obviously, we would only focus on the failures. And the first thing we would do for every failure is to check if this failure is already observed, if this problem is known, and if it's present in our system. In case it is present, we would check its status. Why? Because if the issue is open, if we have active defect, of course our test is going to fail. We don't expect anything else, and we can just disregard it and move on. On the other side, if this defect is supposed to be fixed, we would like to probably reopen this ticket. And finally, if we have discovered a new issue, we would like to report it. Now, can we translate those steps somehow to our framework? Can we take this out of our hands? Let's see. Probably the first step would be the trickiest. Can a framework know when an issue is new? Can a framework have a definition of new problem? Well, why not? If you can feed your framework with up-to-date mapping between every defect that you have and all the tests that it affects, your framework will have all the data. And whenever it detects a new failure, she will know that it is a new defect. Can the framework check the status of an issue in your task tracking system? Well, if she was a person, she would be offended by this question. Of course, it can. And finally, can you walk your defects automatically? You can. It is a little bit tricky because you have to consider how stable is your system and do you really want to walk each and every failure. But you could do this. And a little bit later, we will see how. So now that we have our mapping, and now that we know that everything we do manually, we could do automatically, we are ready to lay down our concept. We came up with a process that consists of 4 separate phases. Starting with getting all your defects and all the associated tests into your framework. This is the basics that you need to get in order for everything else to move forward. Now the next phase would be for every defect to be able to check its status in your defect tracking system. Third phase would be decision making. Now, what decision making are we talking about? Well, we said earlier that if we have a defect which is in open state, which is active, we know that every test it affects will fail. And if we're sure that a test is going to fail, why would we want to run it at all? Why would we want to lose execution time when we already know what the result is going to be? So we decided that whenever we are certain a test is going to fail and whenever we know the reason, we're just going to decide not to execute this test. And we're going to decide to save ourselves some time. And finally, once we've executed our tests, we may want to update our tickets. We may want to close some defects as tested, or we want to reopen them or log new ones. And before we move to the actual implementation, let's take a quick look at the Honeywell test setup so you can understand the context later. From one side, we have a Java test framework, which is built on top TestNG, and we're using REST Assured library for consuming REST services. On the other side, we have a Atlassian Jira bug tracking system, and we've made sure that its REST API is exposed and accessible. The good thing about this solution is that this is just our example setup. You can do pretty much the same thing with any language, as long as you can work with services. And on the other side, you don't need Jira. You just need bug tracking system that can be controlled remotely. And now that we have those two, we can form our testing Voltron. Starting with the implementation. The first step that we need to do is we have to feed all our defect IDs into our system and get them associated with the proper tests. We chose to use TestNG's group functionality in order to do this. And you can see the simple example. We just set the ID of the active ticket as a group for the test that it affects. And this way, we have them connected. The next step would be for us to find a way to actually work with those groups. And this way is provided by TestNG's annotation transformer interface, which you can implement and you can use really simple. The only thing you might want to consider is that with TestNG, everything that you do with your groups will happen before you start executing your suite and not on a test-by-test basis. Moving to phase 2, check your defect state. In order to do this, we will have to get to know Jira's REST API, or at least part of it. We're going to use a really simple get method, for which the only thing you need to know is your defect ID. Jira uses basic authentication, and it would be a good idea for you to have a separate user for your framework. Because if you're only going to query information, it doesn't really matter. But if you decide to move into actually updating tickets or creating tickets, you really want to keep your task tracking history clean. Now you have to make the actual API call from your framework. We've chosen to do it with REST Assured library because, as you can see, it's really clean and neat and pretty easy. You just have to provide your username and password and the defect ID. It does everything for you. Of course, the absolutely same effect can be achieved with pure Java or any other library or technology you choose. And probably the most interesting part is taking the actual decision. Are we going to execute or not? And in order to be capable of taking this decision, you have to understand your task lifecycle. In Honeywell Aerospace, we have 4 basic states for each ticket. The first one is new. This is when your defect is currently active, it is reproducible, and you know that if your defect is in this state, your tests are going to fail. Next, we have our first environment, which is the head branch. And when a ticket is present in there, it means that it's being fixed there probably. Then we have GRC, which is the more stable environment, which is the next step after merging in head. And finally, when your defect is closed or resolved, and you know that you don't expect it to cause any more problems for you. With this in mind, you can create your decision table. This table consists of 3 major criteria, the defect status being the first one. Besides that, you will have to consider some other stuff, like, for example, your defect origin branch. Where did you detect your defect? Because if you have detected it on your first environment, on your head branch, there is a good chance that it is not present yet in RC, and you can execute there your tests, and they're not going to fail. On the other hand, you have the current testing branch, which is where are you going to execute your tests right now? Because again, if you're going to execute your tests on head, then probably most issues are going to be present there. But if you're going to execute them on RC, this is your more stable environment, and you would probably be able to run more tests because you have less defects present there. And based on this, you can create this table and take the decision that you need. Now, it looks a little bit complex to me, and it takes a little bit time to lay it down and to work with it. But if you think about it, you do this every time when you are manually triaging an issue. You go through all those steps, you just do it so fast that you don't know it. But if you sit down and write it and put it in your framework and put it in your code, then you can just sit back and let your Jarvis do it for you from now on. And the final step would be to update our ticket if we want to do this. Now we're again going to use the TestNG power for this, and it provides at least 2 separate ways for you to perform different actions based on your test result post-execution. The first way would be using the after invocation method. from invoked method listener interface. And you can use this method after each test-ng test method. It doesn't matter what its status is, you can access this method and you can perform actions. However, you would have to make sure that this method is actually a test method because it's invoked before methods and teardown methods. Another option that you have is to use the on-test failure or on-test success methods. With this, you will be sure that they will be only called after test methods, but then you will have to split your logic for failure or for success. Again, you will need to learn what services you can use to achieve this. You can go for two separate options. If you're still not sure what you want to do or you're just trying your capabilities yet, you can go for just leaving a comment with execution status, for example. You can use a post service for leaving a message, and so whenever a test has successfully passed, you can leave a comment, okay, you can now close this ticket, and somebody can then go and maybe further verify something and close it. If you feel sure about yourself, if you have really stable framework, and if you're sure that your failures, or at least most of your failures, will mean actual defects, you can even update the issues. If your tests have passed, you can just move this issue to tested or closed or whatever is your next state. Or if the tests have failed, you can reopen it and you can reassign it to a developer. And now after I've explained it, or at least I hope that I have explained it, I'm going to show you a little bit how it works. I'm going to show you 3 basic scenarios. The first time you see how we're going to skip a test because we believe it's going to fail. And then you see leaving comments depending on the test execution status. So let's start. I'm not sure how good you can see it, but we have a Jira ticket with status which is type defect, and it's for implementation, which means it is open. It is applicable for all our modifications, and it's detected in RC, which means it's present everywhere. And now we have our test, which has grouped this very same ticket ID. And we have added some custom listeners to our test.ng suite file. We see the CP listener and annotation transformer that we mentioned earlier. You have to add these in order for the magic to happen. And now let's start executing the test. As you can see, we have noticed that our group actually starts with the Jira ticket ID, so we know this group is special and we're going to handle it specially. Now we are going to actually query the Jira issue status using the REST API. Jira will return you a JSON response that you can parse with any library that you like. And as long as you get the 200 OK status, you're good to go and you can extract whatever information that you want. It gives pretty much all the details that you might want to get for this ticket. You can just select which fields that you care about because you probably will not want to know everything. And now we're going to make some more advanced checks that are related to our own framework. The first thing that we're seeing is that its status is for implementation, which means that the defect is actually active. And our method is active is going to show that it is really active. Its value is true. And also at Honeywell, we have something a little bit more advanced, which is this test applicable because we have different modifications. So even if you don't always run the same code or run it at the same product, you can again check, is it applicable? And as you can see, the test was actually disabled. It is not failed, so your builds are not going to fail and your results are not going to be bad. The test is just disabled and it's not run at all. And now we're going to fix this defect in our system. And we're going to see what will happen if we execute this test again. As you can see, we have a cert fail inside, so our test doesn't really have a chance in life. And running it, we're again going to query the same ticket, but this time we will see that its status is fixed. We're going to execute it, and now we see that our test result is actually failure. And we're going to go through all the tickets which are related to this issue, and we're going to leave a comment depending on the result. Currently we have just one ticket. It is the ticket we observed, and we will leave a comment that this issue, this test has failed. I don't think it's as big as I was hoping, but you can email me later and I can send you the video if you want to see it, or if you have any questions. So now our tests have failed, and we can see in our ticket that we've left a comment stating that it doesn't really work. And now we will leave our ticket in this state. We're going to leave it fixed, but we will remove the assert fail statement from our test so that we now can make it actually pass successfully. And we're going to run it again. It will go through the same steps. It will again see that it can execute it because the issue is fixed, but this time it will take the successful status, and it will know that it can leave a positive comment, or it can close the ticket if you choose to do so. So we can see again the status. The test has passed, and we can see a much better comment now. And this is pretty much the beginning of what you can do if you decide to open the doors of your defect tracking system. It is a bit dangerous. There is a possibility of creating a mess, but it also can save a lot of time and a lot of work that nobody likes to do. So what you get by actually implementing this? You get to cut your monitoring time in half, and you get to decrease your Jira duplicate issues by 36%. You can get almost 18% less pass-through defects, and you can seriously decrease the time to next delivery. At least this is what we got about 1 year after we implemented this. Those are pretty impressive results, aren't they? They're also kind of rubbish, because this is not something you can simply measure in percents. And this all sounds really good, but I can't promise you those numbers. And I can't promise you that you're going to have this chart and you can go to your boss with it. I can't promise you that you're going to cut your monitoring time by 90% or that you're going to deploy to production 10 times a day. You will almost certainly not become as famous as Elon Musk unless you start sending your results to Mars, for example. But there is an upside, because you will definitely reduce your test execution times. Remember all those failures that we're just going to skip now? And we're not just skipping the failures, but also all the before and after methods associated with them. So it is time saving. And also, you will be able to make your Jenkins builds great again, because, as I said, the tests that we know are going to fail will not be skipped, they will be disabled, so they will not appear in your report in any way, and you have a chance of seeing blue build again. And finally, but it's probably the most important part for me, you can get back your valuable time, and you can use it for geeking out or whatever else you feel like. Thank you very much. If you have any questions,